Hi there, welcome to a video tutorial here. We're still looking at algebraic tools in this video. This one's going to deal with solving quadratic equations. This is something that you see in grade 10 math, a little bit in grade 11 math, depending on where you're at. All my videos are based out of Ontario, so depending on the curriculum you're studying. In this one, we're going to be looking at different strategies used to solve quadratic equations. So we'll look at a couple different strategies, and we'll talk about when it's best to use which one. All right, so first of all, solving quadratic equations involves finding the points where the graph crosses the x-axis. These are called the x-intercepts. So in your studies of math, you've probably seen a couple different strategies. You can solve quadratic equations by completing the square, factoring the quadratic formula, which is this nasty expression that you've probably seen, or by graphing. I'm not going to do graphing in this video, mostly because it's inaccurate, and all of these strategies really just give you a better solution. So you won't see graphing, but it can be used to find the x-intercepts if it has to be. All right, so the first thing we're going to look at is completing the square. So the question says solve the following quadratic equation. So we're going to take this guy and we're going to complete the square to determine the x-intercepts. So if you've never completed the square before, I've got a video posted on completing the square, so you can take a peek at that. But I will kind of walk you through this method just to kind of remind you how completing the square works. So the first thing you need to do is you want to take your b term of your quadratic expression. So that's the term, the coefficient in front of x. So you want to take that term, that -6, and you want to divide it by 2 and square it. Now this seems arbitrary, but I promise there is a reason for this. So what you're going to do is take that term, divide by 2, you're going to square it, and you're going to get some number. Now what you're going to do with that number, and again this seems arbitrary and strange, but there is a purpose for it, is you're going to add that number and subtract it after your b term. So you're going to do that in this way. Okay, so you can see I've taken my 9 that I've got from dividing b by 2 and squaring it, and I'm adding and subtracting it after my b term. Okay, now the next thing you want to do is you want to just sort of group your 3 terms that appear first. I've highlighted them in green here. I've just kind of collected my -9, -7, and made -16. And the reason why I've highlighted this trinomial is what I've done is I've made a perfect square trinomial. Now, if you're not familiar with perfect square trinomials, essentially a perfect square trinomial is a trinomial that results from multiplying a binomial by itself and simplifying, right? So if I were to factor this trinomial, I would end up with this factored expression right here. Okay, now if you don't like that, you can just factor this thing by conventional means. And I've got some videos posted on factoring, but you'd find 2 numbers that add to get -6, multiply to get 9, and you'll see that they're actually, both of those numbers would be -3. Okay, so that's why we call it a perfect square trinomial. If you don't like factoring, there's another shortcut which tells you that this number right here, the number you get before squaring your b term divided by 2, will end up being the number you put inside your brackets in this way. Okay, so the goal with completing the square is to convert from a standard form expression to a vertex form expression, right? In this expression here, we can easily pick out our vertex. You might recall from previous math studies that our vertex would be at +3, -16. I'm not going to go over that in immense detail in this video, but that's sort of what we've done is change this thing into vertex form. Okay, once we're in vertex form, it's very easy to solve for the x-intercepts. Essentially what we're going to do is use some algebra to determine the value of x. So the first thing I'm going to do is just move my -16 over to the other side, where I do that by adding. Okay, and now what I want to do is take the square root of both sides here. I want to get rid of that square term, and I do that by taking the square root. So when I square root both sides, I end up with x -3, and I've got a positive or negative answer for the square root of 16. Okay, remember 4 times 4 is 16, but also -4 times -4 is 16. So really I've got 2 situations here, one where my 4 is positive and one where my 4 is negative. And I'm just going to solve these equations separately. I'm going to bring 3 over to the other side, I'm going to bring 3 over to the other side, and I end up with my 2 x-intercepts. Okay, so that's completing the square. I completed the square and then I solved for x to get my 2 x-intercepts. If you don't like completing the square, this is not going to be a fun method for you, which brings me to the second method, which is a little less painful. Same quadratic here, but I'm going to solve this thing by factoring. Okay, so I already talked a little bit about factoring in the previous method, but remember we're going to take that b term and we're going to find two numbers that add to get that b term, while also multiplying to get the c term. Remember, this is a trinomial where the coefficient in front of x squared is 1. So this is what we call kind of like a simple trinomial. If you're a little confused on what's happening here, I've got a video tutorial posted on trinomial factoring. Take a peek at that and then jump back into this one. But in the meantime, we're going to find two numbers that add to get -6, multiply to get -7. We're going to start by looking at -7. This, remember, takes some practice, but you might see right away that -7 plus 1 is -6, and -7 times 1 is -7. So these two numbers satisfy both of our conditions. Therefore, those would be the numbers that we're going to use. You could do this using decomposition, but I'm just going to use the shortcut, which says I can open two brackets, put my x, put each of these numbers after my x, and then I can begin to solve my quadratic equation. So what I'm going to do is I've got two binomials here, and the product of these is equal to 0. Now there's a property that says if one of these is equal to 0, so for instance, if this bracket here was equal to 0, 0 times anything is 0. And that can happen for each of these binomials. So what I can do is sort of solve these two separately, and I do that in the same way as the last method where I ended up with two x-intercepts. So I'm going to take this piece here, this x minus 7, and I'm going to solve for it individually, and then I'm also going to solve for x in my x plus 1 binomial. Okay, and you can see that I end up with 7 and -1. Now comparing that to our solution from the previous method, you see that I get the same x-intercepts. That makes sense because we're solving the same problem, we're just using a different method. So that's factoring. The last method, this is probably my least favorite, is the quadratic formula. I try not to use this thing unless I absolutely have to. Some people swear by this. I'm personally bothered by when people use this thing instead of factoring. You know, you can use this thing every single time, but factoring is a very useful strategy that you need throughout secondary school mathematics. So definitely don't just use this thing in place of factoring. And that's one of the things I see all the time. So anyways, we're going to do this thing. We're going to take this formula and we're going to just sort of substitute all of our values into this thing. So our b term, remember that's always the term including the sign in front of x. Your a term is in front of your x squared, and your c term is the constant at the end of your trinomial. All right, so we're going to substitute those values in to this expression. And you know, this thing is just a monster. It's not pleasant to look at all. And if you're not one of those people who is comfortable with order of operations, this can be a nightmare for you. So I've got -6. That's just +6. You know, I can square -6 to end up with 36. If I multiply these numbers, I get 28. I'm not going to go over all of the math involved in this, but you know, we're just going to add our two numbers together to get 64. And at this point, we're going to end up with a situation where we've got two answers, which makes sense because we have two answers for our x-intercepts in our other two methods. So that's a good thing. All right, so the first thing we'll do is we'll split this thing off into the positive situation, so where I'm adding 8 to 6. Okay, so if I add 8 and 6 and divide by 2, I get 7. I've also got another solution where I subtract 8, and you'll see that you end up with -1. Okay, so you can see in method 3, 2, and 1, we get the same x-intercepts. Makes sense, it's the same problem, just a different method. This quadratic formula, you know, it can be cumbersome. A lot of mistakes happen in here. People forget that, you know, you're actually squaring a negative, so you get a positive. This is a really risky formula, especially for people who, you know, aren't comfortable with math or with their calculators. So just a caution there. So which method do you prefer? This is really a personal thing, but like I said, don't ever substitute factoring for the quadratic formula. I personally find the factoring method the best, but it's really up to you, depending on your needs mathematically. So, you know, just choose wisely. So another quick thing I want to look at here is just determining the number of solutions a quadratic has. You can do this without actually solving the quadratic equation. We're going to do this by using this thing called the discriminant. This is a part of the quadratic formula. It refers to the terms underneath the square root sign, so the b squared minus 4ac. And you can use this to determine how many solutions a quadratic equation has, or how many x-intercepts a quadratic has. Now there's three scenarios that you're going to look at here. Scenario 1, 2, and 3. Scenario 1 is when your discriminant is a positive number, so greater than 0. This tells you that the quadratic is going to have two solutions, and we just saw an example of that. Okay, our discriminant was positive, and we ended up with two solutions. So we're going to cross the x-axis twice. Okay, if you have a discriminant that's equal to 0, you're going to have one solution. And I won't do a full example of that, but essentially, if you do not have a value here, you would just have 6 over 2, and for instance, your x-intercept would be 3. You'd only have one x-intercept. The last scenario is when your discriminant is negative or less than 0, you've got no solutions. Think about it, if I have a negative number under my square root sign, you cannot take the square root of a negative number, therefore you've got no solutions. Okay, and I'll just do a quick example of each of these. We're just going to use the discriminant to determine how many solutions each of these quadratics has. All right, so we're going to substitute our values for a, b, and c into our discriminant, and we're going to see what happens. Okay, be very careful with bedmass here. Remember, you have to square your negative, and you're going to end up seeing that you get a positive number. So 65 does not tell you the number of x-intercepts this thing has. Because this is a positive number, we know from our scenarios that this quadratic will have two solutions. It's going to have two x-intercepts. All right, so just taking a peek at the graph of this thing, that makes sense. The number is greater than 0, so our quadratic has two solutions. You can see our solutions are here and here. Okay, this guy, same thing. We're just going to substitute our values into our discriminant. And in this case, you'll see that you end up getting 0. Okay, just again, be careful with your order of operations here. Now, because your discriminant is 0, we know the quadratic has one solution or one x-intercept. And we see that when we look at the graph, this is just a parabola that happens to touch the x-axis at one point. That's your x-intercept right there. There's one x-intercept. Okay. And lastly, this example here, substituting our values into the discriminant, you'll see that you end up getting a negative number, and as a result, you have no solutions. Okay, so your parabola does not cross the x-axis. All right, so I know I went through those quickly, but feel free to rewind and pause the video as needed. Really, we just looked at solving quadratics using several different methods. We ended up talking about the discriminant a little bit. This thing's kind of useful if you don't actually care what the x-intercepts are, but you just want to see how many there are. So really, that brings us to the end of the video lesson. I'm hoping this helps as you begin solving quadratic equations. This is definitely something that's going to be useful as you proceed in your studies of mathematics. Just remember, you can really choose which method you prefer, but I do caution you to not simply substitute factoring by just using the quadratic formula. Okay, thanks for watching.